Welcome to the Exponential Functions video. In this lesson, we'll be talking about exponential functions, just the basic characteristics of them, and how to pull out the identifying parts. So, talk about linear functions and exponential functions. We're going to compare them, okay? First thing that you need to notice about the difference in linear functions versus exponential functions is their pattern in the table. With linear functions, the y's are going to add or subtract by a constant value. But with exponential functions, the y's are going to multiply or divide by the same factor. Okay, factors are things that you multiply by. The general equation for linear function is y equals mx plus b, where in the linear equation, the m is the slope, but that's also the number that you multiply by, or the number that you add or subtract in the table, and the b is the y-intercept, okay, or where you start on the y-axis when you're graphing. In exponential functions, their general formula is similar in the fact that it's y equals a times b to the x, where a is the y-intercept and b is the growth factor, and this is the number that you multiply by in the table, okay, that you determine you get. And notice how the slope is really the pattern in the table for linear functions. B is the growth factor. That would be the number that you'd multiply, or the multiplication pattern in the table, and the B has an X on it and the slope has an X on it. So that's how you're easily able to compare the equations. The mx in linear over here is similar to the bx in the exponential. Growth factor and slope are similar, adding and subtracting, multiplying and dividing. Okay? When you have linear functions, the m, okay, that determines the direction of the graph. So if you have a positive m, you have a positive graph. If you have a negative m, you have a downwards going or negative graph. If your m is undefined, it's up and down, and if your m is 0, it's horizontal. With exponentials, similarly, just like m is the pattern in the table, b being the pattern in the table, determines our direction of our graph. If the b is greater than 1, the graph goes up. If the b, this is where it's slightly different, we don't really use negative numbers for the b. We'll use numbers that are decimals or fractions that are less than 1 but greater than 0, because we won't use a negative number for the b value. These create a downwards curve. Okay, so linear straight lines like this. Exponential, you get this little bit of a curve, and then it gets really steep really quick. The decay, or the downwards facing one, goes down and then it'll curve out. Okay, when it goes up, it's called growth, and when it goes down, it's decay. Now there is a special case where b equals 1, which you'll never really have in an exponential, because it creates a non-exponential function, and that's when b is 1 and you get a flat line at whatever your a value is. Okay? Technically, it's no longer exponential if you have a b is 1, and so that's in one of the stipulations at the beginning. You kind of define it as b cannot be 1. Standard form. So let's take a look. So you have standard form, that's y equals a times b to the x. A is going to be your initial amount or your y-intercept. Okay? The definitions for that are always going to be the same. B is your growth factor, or this is your pattern in the table. And that's going to be that multiply or divide. Okay? And then X, that's going to be your time. Notice how it's an exponent. That's why it's called an exponential function. So if you're asked to determine is this an exponential function or not, all you have to do is ask, is the letter in the exponent? If you have a variable as an exponent, it is exponential. Okay? Sometimes it gets confused with, okay, quadratics, they have exponents too. But quadratics have numbers as exponents, whereas exponentials have letters in the exponent. Okay? Now, sometimes when you're seeing an equation, you'll have this extra little added k value onto the end. We call it the k, alright? But it's just some number that's added outside of the normal exponentials function, okay? And this is our vertical shift number. It's going to move the graph up or down. If it's a plus, you move it up. If it's a negative, you move it down, okay? So, our first example, we're going to identify the y-intercept and growth factor. Then we're going to determine if this is a growth or decay or neither type of equation. So if you would like, go ahead and work on this now. You can pause the video, and then when you're done, unpause it and see if you're accurate. So the y-intercept for this equation is the a value. So this would be like a times b to the x. So our a is 4, and a stands for the y-intercept. And our b is 2, so our growth factor is 2. And then if we look, this is an exponential growth equation because our b, which is that 2 right there, that b, is greater than 1. And so this means that our general shape will go up as it goes to the right. Thank you for watching the exponential functions general video. This concludes the information.